Hello, welcome to Inside Java. My name is Delabassee, I'm your host for this fourth episode. Today we will discuss a new feature developed under Project Amber, a feature that gets a lot of traction. A few months ago, as part of the Move by Java campaign, we ran a fun JDK feature face-off on Twitter, where the community was invited to vote for their favorite feature. The feature that we will cover today won in the language category. Not only that, after multiple rounds, it also ended in the second spot in the best of the JDK feature face-off overall category. And I'm sure that by now you have guessed that today we will focus on records. For this discussion, I'm happy to have Gavin Bierman with us. Gavin, welcome. Can you start by introducing yourself?
Well, thank you for having me. My name is Gavin Bierman, and I work in the Java platform group. More specifically, I'm part of the design team. So my job, I guess, is to help design future versions of Java.
So today we are here to discuss records. The first question that I have for you is about the semantics. I've seen records, but I've also seen that more and more we say record class. So which one is correct?
That's a good question, actually. So I think the more precise one is record class, because records are a special sort of class, and I guess we'll get onto that a bit later. But that's two words, and people are often trying to find a shorter way to say things. So often people refer to them as records, but the more correct answer is record class.
Okay, I'll try to say record class, but please don't blame me if I don't. I've looked at the JEPs, so the initial JEPs for records. So the first one was in Java 14. It has these definitions. Records provide a compact syntax for declaring classes which are transparent holder for shallowly immutable data. Can you elaborate and explain?
Sure. So I agree, it's quite a mouthful, but let's try and pick that apart and see what all those things mean. So I guess the first important part is compact syntax. So I think we've all written a class where we've noticed that we have to type quite a lot of stuff. And for many classes, you really just want to say that this is a class containing, 2 integer fields or something. But you have to say a lot of other stuff. And we're very keen to reduce the verbosity where it's not serving any purpose. So that's kind of what we're getting at there. The other important word there is actually classes. So records provide a compact syntax for declaring classes. Records are classes, and under the hood, the compiler compiles them to standard classes. There's no big extension to the JVM. There isn't some new data type going on here. So they are classes, and all many of the features of being a class are available to you. The next phrase, I think, is a little more tricky, which is that they're transparent holders of data. And what we mean there is that the particular syntactic form that we've chosen for records is that at the top, after the name of the record, you declare a sort of header which tells you what the data is inside the record. And that's a complete description of the data. So there's no other hidden fields anywhere or something like that. So the idea by transparent is that you can look at the header declaration in a record class declaration, and you know everything. You know all the data that's inside the record value. And that's very important to the semantics of records. And then the final point is about being immutable, or more correctly, shallowly immutable, which is quite a mouthful as well. So what we mean there is that underneath these elements that you declare in the header, they get compiled to fields, private fields inside the class. But those private fields are final, so they're immutable in that sense. So once you've created a record, you can't change one of the components of the record. But of course, you could have put an object in there. So having got the object, you could side effect the contents of the object. So it's just a top level immutability. So we haven't added some concept of deep immutability to Java. Mm-hmm. So I guess just to kind of summarize that in a different way, record classes really just help you to model very simple, plain data aggregates, so aggregations of data in a very simple way, and certainly with less ceremony than a standard class. So perhaps I could just sort of, reiterate some of those things again. So when we declare a record class, we declare its name, and then we declare its state, which appears in the header between two round brackets. And that sort of commits the record class to a particular API that matches that state. So as I mentioned, the compiler under the hood is compiling private fields for those components. You then get automatically generated accessor methods for those fields as well that have the same name as the name in the header. And you get equals method and get hash code methods and toString methods and so on. But you don't need to write any of them. They're all just generated automatically by the compiler. So, this thing between the round brackets, if you look at the draft language specifications for record classes, we refer to that as a record component list. We do that because they are sort of a new thing. You write something like record point int x int y. So those x and y, they get compiled to fields, they get compiled to accessor methods with the same name. So they're not just a field or just a method. So we're trying to give you some hint that there's something subtly new going on here. They're the names for the components, but they serve multiple purposes. Some people, certainly in early discussions with our expert group that people can read design notes, referred to this as like the state description. And again, this is just reiterating the fact that the header in a record class declaration tells you about the complete state of the record values. There's nothing else going on. It's the state, the whole state, and nothing but the state.
Mm-hmm. So can we consider record as tuples?
So they're close to a tuple, but they're nominal. Indeed, when we were discussing this feature, it did come up, should we just add tuples to Java? But that would be quite an intrusive change to the language, because then the JVM would need to understand what a tuple was. That really, I think one of the essences of Java is that it has a nominal type system, types and names by and large. So we just felt that it fitted the language better that this feature would be nominal. So all records have a name. So you can access it as a type through its name, and the components have names too. And that's very much the Java way of doing things, rather than having an anonymous type with components that were accessed by their position and not by a name. So that's quite alien to Java. So in the end, we decided the nominal way was better.
Okay, so that's a nominal tuple.
Yes.
I've seen in the JEP that records are a special kind of classes. So I'd like to understand why they are special classes.
Yes, so they are classes, and I think I've said it already more than once, and I'll say it again. So I think it's very important. They are classes, so it's very much in the style of Java as it is now. But they're a special kind of class, much in the same way that enums are a special kind of class. So enums get their own declaration, syntax, and get some special treatment, but under the hood, they're compiled to classes with some restrictions, and records were designed very much in that spirit. For example, a record class declaration cannot extend another type. We don't want records extending other things, because then the header, the state description, would not be a complete description of the state. But under the hood, we would like all records to be a subtype of some supertype of all these record classes, which is a new type called Java-Lang record. So under the hood, they get compiled to a final class that extends Java-Lang record. But we don't let you say that, because you don't need to. It's implicit, and we don't want you trying to extend some other class and getting into trouble. So we don't let you do that. Another restriction, for example, is we don't let records declare native methods. That, again, is just because we can't see why anybody would want to do that. Records are supposed to be just a simple aggregation of data. So we just want to remove the things that really don't fit in a record class declaration, but obviously these things have a good role in Java and standard class declarations, but for record class declarations, they don't make sense. So we've removed some features. But one other important difference between standard Java class declarations and record class declarations is around the notion of a constructor. So Java classes get a default constructor automatically, but that doesn't really make sense for a record because you don't ever want to construct a record value that hasn't been initialized with the values for the components. So record classes have a notion which we call a canonical constructor. So your header contains what looks like a formal argument list. And it basically, the canonical constructor for the record class is the constructor that takes those arguments as its argument list. And obviously you would expect it to assign values to the internal fields. So the idea is that if we go back to our example of a record class point, which has a header that says int x, int y, then the constructor, the canonical constructor for that record class would be the one that takes an integer x and integer y value.
Okay, and that one is automatically generated.
Yes, that's right. So this is really one of the great features of records in terms of reducing syntactic noise in your code, is that the compiler can just roll a canonical constructor for you, because the standard canonical constructor would be taking, in our example of point, x and y arguments and assign them to the private fields x and y. Well, the compiler can roll out that code for you, no problem. So the compiler can roll out the private field declarations for you, the accessor methods for you, the canonical constructor for you, and the equals toString hashcode methods as well. So you don't have to mention any of those. The compiler does that for you under the hood.
But what if I want to do some validation?
Yes, so that's a great question. It's actually very interesting because that came up as we were designing record classes. We noticed that there was so many record classes we didn't need to define our own canonical constructor. But for some of them we did, because what we wanted to do was either verify that the arguments being passed were correct. I know, for example, maybe you don't want negative integers or something like that, or you don't want an empty string. And so if you get one of those erroneous cases, you throw an exception and then you do the standard assignment of the fields to the values. Or you might want to normalize the arguments in some way. So maybe instead of throwing an exception for a negative value, you just negate the value and make sure it's positive. But then after that, we would then assign the values to the fields. And we realized that this was a pattern where people would either not write a canonical constructor, or the canonical constructor that they did write just did either a verification of the arguments or normalizing the arguments, and then they did the assignment. And we realized that there was still some syntactic clutter there that we could remove from people, because really the logic that people want in the class declaration is my constructor would like to validate or normalize the arguments in this way, and I would like the compiler to generate all those assignments for me. So in the end, we decided to support that as a new style of canonical constructor, which we call a compact canonical constructor. And this constructor, in fact, you don't need to give the argument list, because that can be inferred by the compiler from the header. And you don't need to write the assignments either. So the compiler looks at your code and sees that you haven't assigned any of the values to the fields, and it inserts that code for you. You end up with some quite beautiful code where your constructor just exposes the essential facts of what it's doing, which is I'm validating the arguments or I'm normalizing the arguments, and the compiler unrolls all the other code for you.
Okay, so compact constructor was a good name for that feature.
Yeah, I hope so. That's right. So I think it's, keeping on this discussion about how record classes differ from standard class declarations. There are some restrictions which enable you to get all this beautiful help from the compiler of unrolling bits of code for you. So in particular, record classes can't declare any instance fields. We want the fields should be declared in the header, nowhere else. So we don't let you declare any others, because that would defeat the whole purpose of records declaring in the header all their state, a complete description of the state. And, obviously, therefore, there are no instance initializers and things like that. As I mentioned earlier, we don't want inheritance between record classes because that would enable a record class to have state that was not in its own header. A record class is implicitly final, so you can't create hierarchies of these things. All records implement this new superclass, Java lang.record, but they can't subtype each other and they can't be abstract and so on. And as I've mentioned, we want the fields to be immutable because the natural notion of a tuple, even a nominal tuple that we have here, is that you don't mutate the data. Otherwise, the sort of semantic properties that you're expecting around equality and so on wouldn't hold. So the private fields that store the values, those are final. So, if you have a class and you're wondering, could I make this a record? So there are some requirements that you're going to need to satisfy before you can simplify the declaration and make it a record class declaration. I think the point here is that, Java classes are a fantastic thing. The whole world can be modeled with classes, and to a certain extent, the whole world is modeled as Java classes. But there are cases where, whilst you can model them with classes, it's a lot of work, and you want to declare something a little bit more high level, much like with enums. Before enums were added to Java, people wanted something like an enum and they had to roll their own, and it's quite painful. And we see that there are many cases where people need simple data aggregation. They need simple data types just storing data. And I think this is a reflection of, the changing world of software, that when Java was initially designed, there were obviously a set of applications and scenarios that people were thinking about, but the world has changed. We see a lot of code, for example, a lot of machine learning code, a lot of streaming code, a lot of big data code that were never imagined by the initial designers of Java. And when you look at those code bases, people are trying to declare temporary aggregations of data as they're processing large arrays and so on, as you do commonly in machine learning applications. Really, these are the sort of sweet spots for records. They just give you a very simple way of defining an aggregation of data.
But on the other hand, if I'm creating too many records, given that there are classes, I will end up with a lot of classes.
We would expect that people would start creating their own libraries of useful records and so on. So I think we will probably see that in the future. But I think the other advantage or the other feature we're adding is the ability to declare classes locally. This is an important aspect of the design. So if in a method, for example, you are, let's say, processing a stream, so you're streaming over a large amount of data and you're creating, say, another smaller stream of intermediate values, then there you just want to declare a local record to that method. In the latest version of records, we support local declarations of records, so they're just private to the method. I think that would help in that respect.
Okay, so that means that I can create directly within my methods the records?
That's right. So you can declare locally in a method a record class that's useful to you there, but you don't want to export it outside. You're just using it temporarily. And then you have, say, your stream of local record type values, and then you process those and produce, a stream of floats, and that's what you emit from the record.
Okay, that makes sense. So we've discussed some of the restrictions that records have, the record classes have.
Mm-hmm.
In exchange, we get the benefit of records. So as I understand, for the rest, they are just normal classes.
That's right. So if we're often asked, but I need to declare a method on my record. No problem. You can declare methods. No problem. They're just standard classes under the hood. Some people say, I want to declare some other constructors. I need some other constructors, not just the canonical one. No problem. You can define other constructors. Obviously, they have to call the canonical constructor because we don't want to end up with records that have uninitialized components. But other than that you can define your own ones, no problem.
Okay, and we can also override the implementation that are generated by the compiler.
Yes, that's an important fact. So it is often the case that the accessor method that's rolled out for you by the compiler or the canonical constructor that's rolled out for you is the one you want, but not always. Sometimes you might want to, for example, like do something clever about caching or something like that. Maybe you have some big values in there and you want to do something clever. So if you want to define your own accessor method for a component, you can do, and the compiler notices that you've defined it, and so it won't roll out one for you. It sees that you've declared one yourself. And in fact, we've actually amended the override annotation, so you can actually mark an accessor method with the override annotation just to confirm to yourself that you have actually overridden an accessor method. So if you somehow screwed up with the signature of that, the compiler would say, well, hold on, this doesn't override an accessor after all. So that we're hoping that would be helpful to people. Similarly with the canonical constructor, if you want to do something slightly different than just assigning the values to the fields, then you can write your own one, and the compiler obviously checks it but doesn't roll out its own one automatically. It sees that you've done it yourself.
Okay. So in a nutshell, records, we've talked about the restriction. They are regular classes. Having said that, there's a big difference when it comes to serialization.
Yes, that's right. So serialization is, often the thing that people
like to hate,
like to ignore. It's not the best part of the world to live in, but it's an important one. And in fact, we saw here actually a great opportunity to improve the serialization story for record classes, because the serialization feature of Java, whilst complicated, is fantastically powerful, and many people use it to great effect. But for records, it doesn't really seem suitable to allow people to have all of that power, because the values are very simple. So we don't see that there's quite the need for all of the arbitrary power that you have for classes. So actually what we're proposing is a much simpler serialization story, which has much better semantic properties. So in particular, the serialization, so if we take the two halves, serialization, deserialization, the serialization of records is required to just be based on the state components. So the idea is really the only things you can serialize are genuine record values. And then when you deserialize, the key difference that we have between a record class declaration and a class declaration is this difference between the default constructor and the canonical constructor. Now, for standard serialization, the default constructor, in fact, the default constructor for your supertype is called, and then you sort of assign the values as you read them in from the stream. But for records, we have this beautiful canonical constructor, which is the constructor that takes the values of all the components, and you're not allowed to have any other component values. It takes them all in and constructs the value. So deserializing a record object invokes the canonical constructor. And this is both a much simpler model, but in fact, more importantly, it's much more secure, because the record values that you serialize are real record values. But the problem is the other direction, right? When you're deserializing, okay, you're deserializing all these bytes, but you're hoping that they came from a genuine value, but you don't know. And that's, where the world of pain of serialization really resides. But for record values, this is not possible, because you come in through the canonical constructor. And the canonical constructor, if we discussed before, for many simple record classes, has some validation logic in it, and we provide this nice compact syntax for you to declare that. So now when the value comes in, your canonical constructor is used, and the canonical constructor can check the values coming in. It's not possible for you to deserialize and create a record value that isn't a valid record value. So I think the sort of motto here is impossible objects or impossible record values are impossible. And this was kind of, the dream of everyone who has to deal with serialization, deserialization. And for records, we can achieve it. And this is a great advantage of record classes.
Yeah, that's nice. Okay, let's talk now about where we are. So records were first previewed in Java 14. The second preview is right now in Java 15. Records are slated to be made final and permanent in Java 16.
Yes, that's right. So we are planning to finalize records in 16. I encourage everyone to play with the 15 implementation, and this is now your opportunity to tell us if there's anything you think should be changed from the design. But we're pretty confident we're at a sweet spot.
Okay, is there any change that you want to highlight between the first preview and the final version that should be in 16?
So there are some small amendments that we've made, mainly around the feature of local records. So we supported them in the first version, but we kind of have extended it a little bit more. So in particular, we realized that local records would be static, implicitly static, because we don't want them to grab state from outside. And that reminded us that we have other types in the language that you can declare locally and are implicitly static, i.e. enums and interfaces. So we took the opportunity to bring those in for the ride as well. So as part of the records feature, you get local enums and local interfaces. We're planning on this, the 16 version, the final one, we'll just extend that out a little bit and allow it for nested classes as well. So we'll extend out just a little bit there. But other than that, the feature is pretty robust. We've not made it very many changes at all across the three versions.
Okay. And I have a confession here. As a developer, I find records very addictive. Once you start to use them, it's hard to not use them.
Right. That's good to hear. That's what we want.
Good. So let's quickly talk about what's coming next. We know that records should be made final in 16. The JEP that finalized records in 16, it says, we expect a future version to support deconstruction patterns to allow powerful pattern matching. Can you comment on that?
Yes, I'd love to, in fact. So I think this is one of the very cool features of Project Amber, which is the umbrella project that's supporting records and other changes that we're making to the language, in that we have a lot of things going on. And at the moment, they're just at the early stages. So we have records, we have other features like sealed classes and pattern matching in instance of. And at the moment, they look a little bit independent, but in fact, they are all going to come together in a nice and harmonious way. So in fact, we're hoping that it will be a situation where the final language will be more than the sum of its parts. So we're in future versions, we're planning to start combining these features. So if we come back to records, we have this notion in the language that we're pushing, which is this idea of pattern matching in instance of. So very simply, this allows us to extend the instance of operator to not just ask whether something is an instance of a type, but also we change the right-hand side to move from a type to a pattern. And a pattern, just abstractly, is a test of some kind. And if the test succeeds, some variables are bound. So in the first version of pattern matching, for instance of, the only pattern that we're going to support is a type test pattern. So you, instead of saying, is E an instance of type T, you'll be able to say, is E an instance of TX? And the idea, the semantics here is that you test whether it has the runtime type T, and if it does, that value is cast to T and is assigned to the variable X in this case. So this enables us to remove many casts from the world of Java programs, which is a very pleasant side effect. Now, this seems like a very modest thing, but we have big plans for pattern matching. I explained this as saying that we were only offering one simple pattern, the type test pattern. The next pattern that we're going to add is actually a record pattern. So there you might say, is the expression an instance of point var x var y? And so this is a pattern that we could call a deconstruction pattern, because it's doing more than that type test pattern that I described, because it's both testing whether E has the type point, is it a point? But if it is, I would like to pull it apart and extract the values and assign it to the local variables x and y. So this opens up now a world of writing really quite compact code where you can start pulling apart values just with one pattern. And this is the fully compositional model, which is a very nice feature. And what I mean by that is that you might imagine that you have, let's say, a rectangle record, and its two components are both point records. Now, in your pattern, you can nest two deconstruction patterns together. So you can say, is E an instance of rectangle brackets point brackets var x var y comma point var a var b? And this is a very compact way to say, is it a rectangle containing 2 points? And if it is, I would like the 4 point integer values to be called x, y, a, b, which is quite a lot of code going on with very few characters. We in fact have quite far-reaching plans for pattern matching, but beyond records, we're looking at adding them to all classes, in fact, and with arrays and with other literal values and all sorts of things. We also have a story around serialization with pattern matching as well. So we have great hopes for pattern matching as a feature. And I think the exciting thing is not just that feature, but the fact that these language features actually come together and provide something even more powerful. So records will come together with patterns. Patterns will come together with sealed classes. We start to get an even richer picture of the language in the future.
So yeah, a lot of exciting stuff.
Yes, that's right. And we've got some other things as well that we're hoping for, more specifically around records. The common question that I get is around copying records. So people say, well, it's all very well to make a record value immutable, but I often find that I have some record value and I'd like another one of those, but with just one of the components changed. And there's no way for me to do that. I have to create a new record from scratch. Now, if the record is very simple, that's not such a big problem. But as you described, records are a little bit addictive. So you can often end up having quite a lot of them, and maybe some of them get quite large. In our future plans, we hope to support some very compact syntax, which we call a sort of wither. So the idea here is a very compact way to declare that I would like a fresh record based on an old record with a small delta. And we're going to give you some very compact syntax to express that sort of copying and small amendment, which we hope will make records even more useful.
Sounds very exciting.
Yeah.
So, I guess we had a good discussion. I mean, that was a very useful overview of records. So I think it's time to wrap up. But before we do so, this show is called the Inside Java Podcast. So can you give our listener a peek inside the day of Gavin?
Sure. I'm a language designer, so I really have a very much a dream job, because I get to play around with the design of Java and discuss with colleagues how we see Java going. I get to collaborate with the compiler writers, and we get to prototype things and so on. So it's a lot of fun. It's a sort of mix of writing design documents, writing real documentation, writing tests for the compiler, writing new bits of the compiler. So it's sort of no 2 days are the same. So it's very exciting from that point of view. If you take a sort of broader day, so outside the office hours, Well, I have 3 kids, so that keeps me pretty busy.
That's a full-time job.
That's a full-time job as well. That's right. Beyond that, I guess my 2 main interests are football. I'm a very keen football fan. I support a team called Queen's Park Rangers, who are not so successful, but
Let's clarify for the audience, you're from the UK, so you mean real football, right?
I mean the old football, soccer for American listeners.
The real one, yeah.
That's right. The other thing I spend quite a bit of time on is playing the guitar.
Playing guitar, sweet. Kevin, we'll wrap up here.
Great. So, well, thank you. Thanks very much, David. It's been great fun. Thanks for having me and giving me this opportunity to talk about the future of Java.
Thank you very much for this conversation. I really enjoyed.
Thank you.
Thanks again, Kevin. Bye.